Hello sir, I am Raghavendra. Today I am going to present a seminar on IPv6. So let's begin with the outlines of this. These are the outlines of my topic. Problems with the previous version IP version 4 and a basic IP version 6 protocol and IP version 6 features. I mean auto configuration, quality of service, security and mobility. So first to see what is IP, Internet Protocol. It transports a datagram from source host to destination via several intermediate nodes. Here, if the service is unreliable means it loses the packets or duplicates or out of order delivery. If the service is connectionless means each packet is treated independently. So let's begin with the IP version 4 header format. So here, first is the version which is 4 bits. It specifies the version of the IP protocol, and next is the header length which is of 4 bits. It specifies the length of the header. Next one is the type of service which is 8 bits. It allows the different types of service to be requested, and this is the total length which is 16 bits. It maximum packet size here 2 per 16, I mean 65,535 bits. Here these three fields are for fragment control. I mean first one is the identification which is of 16 bits. All fragments of a single datagram have the same node fragment. Next one is the flags which is of 3 bits. Here the first bit reserved, I mean it must be 0, and the second bit is for don't fragment, and the third bit is of a more fragment. And the fragment offset which is of 13 bits and used for reassembly of packet. Here the time to live, I mean which is of 8 bits. It initially set by the sender, I mean he can set up to 255, and it is decremented by each router, and it discards a packet when TTL is equal to 0 to avoid infinite loops. And this is the protocol which is of 8 bits. The value indicates what is in the data field, example TCP or UDP. This is the header checksum which is of 16 bits. It checks for the error in the header only, but bad header can harm a network. So if the error found, packet is simply discarded. This is the source address and destinations which is both of 32 bits long. The last one is the options, a padding, the times, for example timestamps, record route and source route. So why we considered the IP version 6 means the problems here with IP version 4 is a limited address space. I mean IP version 4 has a 32-bit address and a flat addressing, I mean only net ID plus host ID with the fixed boundaries, and results in the inefficient use of address space. The class P addresses are almost over, and addresses will exhaust in the next 5 years, and IP version 4 is a victim of its own success. And the other problem is the routing table explosion. I mean IP doesn't permit route aggregation, I mean limited supernetting possible with the new routers. Mostly only class C address remain. Number of networks is increasing very fast, I mean number of routes to be advertised goes up, and very high routing overhead, I mean lot more memory needed for a routing table, and a lot more bandwidth to pass routing information, and a lot more processing needed to compute routes. The next one is next problem is header limitations. I mean maximum header length is 60 octets, maximum packet length is 64k octets, and ID for a fragments is a 16 bits, repeats every 65,537th packet. So we'll and a variable size header, I mean it slows processing at routers, and number of ordering options, all routers need to look at all options. And the other limitations of IP version 4 is the lack of quality of service support. I mean only 8-bit types of service field which is hardly used, and a problem for multimedia services, and no support for security at IP layer, and mobility support is limited here. So we can see here that the difference between the IP versions 4 and 6. this the technology scope, IP services, the addressing range for version 4 is 32-bit and network address translation, and for version 6 is 128-bit and multiple scopes. And for auto configurations in IP version 4 it's a DHCP, and version 6 serverless reconfiguration and DHCP. And if you look at security, means here in version 4 it's IP security, and version 6 IP security mandated and works end to end node. And for the mobility, means in version 4 it's a mobile IP, and in version 6 mobile IP with a direct routing. And the quality of service for IPv4 is a differentiated service and integrated service. It's the same, is common for both of this. And IP multiclass means here IGMPR, PML, multiclass BGP, here MLD, PAM and multiclass BGP, and scope identifier, which is the other difference. So first we look at what is IPv6. It's also known as IPNG, IP next generation. It's a new version of the internet protocol, primarily designed to extend the address space, enhancements and new features. So the distinctive features in IP version 6 are header format simplification, expanded routing and addressing capabilities, improved support for extensions and options, flow labeling capability for a quality of service, auto configurations and neighbor discovery, authentication and privacy capabilities, simple transition from IP version 4. So you can see here the IP version 6 header format. The first one is the version, which is a 4 bits. The version identifies the version of IP used to generate the datagram. This field is used the same way as in IP version 4, except of course that it carries the value 6. Next one is the traffic class, which is of 8 bits. This field replaces the type of service field in the IPv4 header. It is used not in the original way that the TOS field was defined, but using the new differentiated service method defined in RFC 2474. The RFC actually specifies the quality of service techniques for both IP version 4 and IP version 6. Next one is the flow label, which is of 20 bits. This large field was created to provide additional support for a real-time datagram delivery and a quality of service features. The concept of a flow is defined in RFC 2460 as a sequence of datagrams sent from a source device to one or more destination devices. A unique flow label is used to identify all the datagrams in a particular flow, so that routers between the source and the destination all handles them the same way, to help ensure uniformity in how datagrams in the flow are delivered. For example, if a video stream is being sent across an IP internetwork, the datagrams containing the stream could be identified with the flow label to ensure that they are delivered with a minimal latency. Not all devices and routers may support flow label handling, and use of the field by a source device is entirely optional. Also, the field is still somewhat experimental and may be refined over time. Next one is the payload length, which is of 16 bits, and this field replaces the total length field from IP version 4 header, but it is used differently. Rather than measuring the length of the whole datagram, it only contains the number of bytes of the payload. However, if extension headers are included, their length is counted here as well. So in simple terms, this field measures the length of the datagram less than 40 bytes of the main header itself. So next is the next header, which is of 8 bits. Next, this field replaces the protocol field and has two uses. When a datagram has extension headers, this field specifies the identity of the first extension header, which is the next header in the datagram. when a datagram has just this main header and no extension headers, it serves the same purpose as the old IP version 4 protocol field and has the same values, though new numbers are used for IP version 6 of common protocols. In this case, the next header is the header of the upper layer message the IP version 6 datagram is carrying. Next is the hop limit, which is of 8 bits. This replaces the time to live field in the IP version 4 header, and its name better reflects the way that TTL is used in a modern networks. Next is the source address, which is of 128 bits, which is of 128 bits, the IP address of the originator of the datagram. As with IP version 4, this is always the device that originally sent the datagram. As well, the destination address, which is of 128 bits, of the intended recipient of the datagram, unicast, anycast or multicast. Again, even though devices such as the routers may be intermediate targets of the datagram, this field is always for the ultimate destination. So as I told that IP version 6 header field version number which is a 4-bit field, value is always 6 as I told. The flow label is 20-bit field used to label the packet requesting special handling by routers. The traffic class, which is of 8-bit field, used to mark the classes of traffic, and the payload length, which is of 16-bit field, length of the packet following the IP version 6 header in ops. The next header is of 8-bit field, the type of header immediately following the IP version 6 header, and the header fields. And hop limit is of 8-bit field, decremented by 1 by each node that forwards the packet, and packet discarded if hop limit is decremented to 0. As like in IP version 4, if the TTL equal to 0 means it discards the packet. And the source address is of 128-bit field, an address of the initial sender of the packet, and the destination address, which is of 128-bit field, an address of the intended recipient of the packet, may not be the ultimate recipient if routing heading is present. So header changes from IP version 4 as longer address here. I mean, there it was 32 bits, here 128 bits. The fragmentation field moved to separate header. Header checksum removed here, and header length removed. Length field excludes IP version 6 header, and type to live there, here hop limit, and the protocol here next header. 64-bit field alignment, and the type of service replaced by a flow label traffic class. And the extension headers, it's less used functions moved to extension headers, only present when needed, and the processed only by a node identified in a IP version 6 destination field. It's much lower overhead than IP version 4 options. Exception here is the hop by hop option header, and it's eliminated IP version 4's 40-byte limit on options. And it's currently defined extension headers, I mean hop by hop, routing, fragment, authentication, privacy, and end-to-end. Order of extension header in a packet is defined. Headers are aligned on 8-byte boundaries. And the address types of IP version 6 is unicast, I mean address for a single interface. Multicast means identifier for a set of interface. Packet is sent to all these interfaces. Anycast means identifier for a set of interfaces. Packet is sent to the nearest one. That is the difference between these. IPv6 addresses, I mean here the address field is a 128-bit addresses. Multiple addresses can be assigned to an interface. Provider based hierarchy to be used in the beginning. Addresses should have a 64-bit interface IDs in a UI64 format. The following special addresses are defined: IPv version 4 mapped, IP version 4 compatible, link local, site local. And routing in IP version 6, hierarchical addresses are to be used. Initially, only provider based hierarchy will be used. Longest prefix match routing to be used, same as the IP version 4 routing under CIDR. And the OSPF, RIP, IDRP, ISIS, etc. will continue as is. And easy renumbering should be possible. Provided selection possible with any cast groups. And the quality of service capabilities here is protocol aids quality of service support not provided. Flow labels are the to identify packets needing same quality of services. 20-bit labels decided by a source. Flow classifier means flow label plus source or destination address. 0 if no special requirements, and uniformly distributed between 1 and for those FF. The traffic class is which is of 8-bit value, and the routers allowed to modify this field. And the security issues are provision for authentication header. It guarantees the authenticity and integrity of data. And the encryption header, it ensures the confidentiality and privacy. And the encryption modes are transport mode and tunnel mode. And independent of the key management algorithm. And the security implementation is mandatory requirement in IP version 6. And the mobility support in IP version 6. So mobile computers are becoming commonplace. So the mobile IP version allows a node to move from one link to another without changing the address. So that is the advantages of YOM. That a movement can be heterogeneous. Node can move from an Ethernet link to a cellular packet network. The mobility support in IP version 6 is more efficient than mobility support in IP version 4. And there are also proposals for supporting micro mobility. And we see the neighbor discovery. Router discovery, here it determines a set of routers on the link. Prefix discovery means a set of on-link address prefixes. Parameter discovery means to learn the link parameters such as the link, MTU, or internet parameter like hop limit, etc. And address auto configurations, address prefixes that can be used for automatically configuring interface address. Address resolutions, IP to link layer address mapping, and duplicate address detection. Also route redirect means inform of a better first of node to reach a particular destination. And the last is the additional features is anycast addresses. Multiple nodes on a link may have this address, and all those nodes will respond to an NS message. Host will get a multiple NS messages but should accept only one, and the message should be tagged as a non-override. The proxy advertisements or routers may send a NA on behalf of others, and it's useful for mobile nodes we have mode. Thank you, sir.